Hello again, Math 10Cs. In today's lesson, we are going to begin the last unit of study in Math 10C, and that unit is going to involve dealing with systems of linear equations. So we're just going to take all of the things we learned in the last 3 units dealing with linear relations, linear equations, and just take it a little bit of a step further. Okay, so we're going to start off by doing a little bit of a review of some graphing. Okay, so the book here tries to set up the context of the lesson by giving a word problem. I don't think that's really the appropriate way to like start off by like teaching about like what a system of linear equations is. So I'm just going to ignore all the word problem aspect of this. I'm just going to focus on the equations themselves. Okay, so this is going to be a little bit of a review of how to plot, how to make straight lines given an equation. Okay, so I have 2 equations here. So I have this one. I have 3x plus y equals 11. I'm going to call that line 1. And I have this second equation, which is 2x plus 3y is equal to 12. And I'm going to call that one line 2. Now, what it says is draw each of these graphs on the grid without using technology. Okay, so we're going to do that by hand. Okay, so let's start off with line 1. Now, line 1 is currently in a format that we cannot use to plot a straight line. Now, the way I'm going to do it, and there's like 3 different ways that you can use to like plot a straight line. The one that I prefer to do is the method where you write the equation in y equals mx plus b format. You identify the y-intercept, you identify the slope, and you form a line based on the y-intercept of the slope. So the first thing I'm going to do right here is I'm going to manipulate this equation so I can get it into y equals mx plus b format. So the way to do that is get y by itself. So I'd subtract 3x, and then I would have my equation y would be equal to negative 3x plus 11. Okay, now from this equation, my slope, m, would be equal to negative 3, and my y-intercept, b, would be equal to 11. Okay, so on the graph, I'm going to draw my y-intercept at positive 11. So it's going to be at the very top here. Now, what I'm then going to do is I'm going to draw a slope triangle, okay, starting from that point. Now, the way this works again is we know that m is equal to rise over run. And in this case, we have negative 3 would be equal to rise over run. Now, we can pick whatever values of rise and run we want, as long as the rise divided by the run is going to be equal to negative 3. So I'll just pick negative 3 over 1. So I'm going to plot a rise of negative 3, and I'm going to show a run of positive 1. So what this would look like, so I'll go to a different color, is starting at the y-intercept, I'm going to go down by 3 because my rise is negative 3. So we go down by 3. Okay, so I can say my rise is equal to negative 3. And then I'm just going to go across by 1 because my run is positive 1. So my run here would then be 1. Now, at the end of this slope triangle, we can plot our second point. So my second point is going to be located right here. And all I need to plot a straight line is I just need 2 points. So I just need to draw a straight line that goes through those 2 points. And if you want to, by the way, we could just fill in the slope triangle. Okay, now I'm going to need to grab a straight line to actually plot this correctly. And then once again, you guys should be, or you should be using rulers to do this. Okay, so let's pull a line on here, and let's make it, what color? Let's do, I don't know. You know what, red's fine, okay? So let's see if I can get it to go through here. Yeah, it's pretty mediocre. Here, let's do it like this and move it over a bit. Oops, that didn't work. Okay, let's go back down here. See if I can take that line and I can grab it. And this is much easier for you to do because all you have to do is just draw the line. Okay, that's not bad. All right, and then if we want, we can, at the end of the graph, we can just draw a couple of arrows just to show that the line just continues to move on. Okay, so that is line 1. Okay, now line 2. So let's go down here. So line 2 has an equation of 2x plus 3y is equal to 12. And let's do the same thing again. Let's get like y isolated. So I'm going to subtract 2x from both sides, subtract 2x, and then I would have 3y would be equal to negative 2x plus 12. And then let's get the y isolated. So I'm going to divide this side by 3, divide that side by 3. So that's going to make the 3's on this side cancel. And then the way to properly express this is basically take the each numerator and divide by each term in the numerator and divide by the denominator. So then this would look like y would be equal to negative 2 over 3 x plus 12 over 3. But 12 over 3 we can actually, the divides evenly, so we can turn it into negative 2 over 3 x plus 4. Okay, so here my slope m would be negative 2 over 3, and then my y-intercept would be 4. Okay, so let's plot this one. So this one's going to have a y-intercept of 1, 2, 3, 4. So that's going to be located right here. And then I want to draw a slope triangle that has a slope of negative 2 over 3. So the way we're going to do that, so I'll do this one in purple, is slope is rise over run. So the numerator represents the rise. So from the y-intercept, we're going to go down by 2. Okay, so the rise is equal to negative 2. And then we're going to run across by 3. So we're going to go across by 1, 2, 3. Okay, and that's my run, which is equal to 3. And then we have our second dot is where the slope triangle ends. And if I want, I could just quickly sketch and complete the slope triangle. Okay, now we'll plot a straight line. So I'll grab a line here. And let's make this line, let's do green. Okay, so I'll try to make it go through these points as best as I can. Okay. I don't know. That's like very mediocre. Okay, good enough though. Okay, and then we'll just draw the arrows at the end to show that line is continuous. And this is line number 2. Okay, now it says B. So that's just a quick review of like how we would plot if we're given an equation, how we can plot a straight line by hand. Now B says the graphs of these equations intersect at a point. State the coordinates of that point, and then explain what it represents in the context of the question. We're not going to worry about the second part of that because we're not going to worry about this as a word problem. Okay, now, if I'd actually drawn this graph like really, really accurate with a ruler as opposed to using shapes in a Smart Notebook, I would notice that there's an intersection point at, it should be about right here, okay? This is my intersection point for those two lines, okay? So it wants to know, like, what is this intersection point? Okay, so this is my intersection point of the lines. Okay, so what are the coordinates of this intersection point? Well, if you go down to the x-axis, it would hit the x-axis at +3. And if you went over to the y-axis, it would hit it at 2. Therefore, this intersection point would have coordinates of 3, 2. Okay, we're going to come back to this in a second now, because the intersection point of these two lines is actually going to be quite significant. Okay, let's go to the next page. Okay, I'm going to skip over a bunch of this text here. I'm going to start down, we're going to start down here. Okay, it says the equations 3x plus y equals 11, so that was line 1, and 2x plus 3y equals 12, when considered at the same time, is what we call a system of equations. Whenever you see that word system, this is kind of the way we describe it in science, or in physics mainly, is a system is a collection of objects. So a system will have 2 or more objects involved. What are the objects here? There are a couple of lines. So on the previous page here, so this graph shows 2 lines at the same time. So what we call them is we call them a system of linear equations, because we have line 1, which is one linear equation. We call line 2, which is a second linear equation. Because we have 2 or more linear equations, we can call it a system. Okay, a system consists of 2 or more objects. In this case right here, the objects are my lines. Now, a system of equation has something called a solution. Now, a solution to a system of equations is graphically the point where the 2 lines intersect. So on this page here, my solution to this system is x equals 3 and y is equal to 2. Now, what's the significance of a solution? Okay, it says the solution to the system of equations is x equals 3, y equals 2. That's because x equals 3 and y equals 2 will satisfy each equation in the system. Okay, let me show you what they mean by this. Okay, so let's go over here and let's take my 2 equations. Okay, so we have line 1, which has an equation of 2x plus 3y is equal to 12. And I have line 2. And then I have the equation is, whoops, this one's line 1, or this one's line 2. Okay, that one's line 2. How about this? Okay, let's just erase that. Just so that I'm getting kind of confused here. Okay, let's make it the correct lines. All right. Okay, line 1 is 3x plus y equals 11. Line 2 has to make is the equation 2x plus 3y is equal to 12. Now, what happens is if you take this value of x and plug it into both these equations, you replace x with 3. And if you take this value of y and you plug it into both equations, if you plug it in, both sides of the equation need to be equal to each other. So that's what a solution of an equation is. A solution, the values of x and y you determine have to work if you plug them into both the first equation and the second equation. Okay, well, let's just actually plug the numbers in and see what they look like here to make more sense of this. Okay, so I'm going to replace x with 3 here. So this would be 3 times 3 plus 2 is equal to 11. Replace y with 2. So 3 times 3 is 9 plus 2 is equal to 11. Therefore, you have 11 is equal to 11. So we say that x equals 3, y equals 2 satisfies the equation, because if you plug in those numbers into the equation, it actually makes the equation balance properly. It gives you an 11 on both sides of the equation, an equal number. And then this will also work for the second equation. For the second equation, if we plug in x equals 3 plus 3 times y, which is y equals 2, which equals 12. 2 times 3 would be 6. 3 times 2 would be 6. And then this would be equal to 12. Therefore, you'd have 12 is equal to 12. Okay, so let's go back down and then just kind of like read what it says again. Okay, it says the solution to this system is x equals 3, y equals 2. That is because x equals 3 and y equals 2 satisfies each equation in the system. And again, what that means is by satisfies is if you actually take the values of x and y, plug it into the equation, and then evaluate the expressions, you need to get the same number on both the left and right hand side of the equations. And in terms of like what is the solution, graphically, it's going to represent an intersection point on the graph. So our focus today is just going to be on figuring out what's the solution to our system of equations graphically, and that's going to be looking at the intersection point. In the lessons later on in the unit, we're going to algebraically, without graphing, try to figure out what the solution to a system of equations is going to be. Okay, let's keep moving forward though. Okay, so it says example 1. A system has been represented on this grid. Again, system, because you have 2 or more lines. Says state the solution. So again, the solution to a system of equations is going to be represented by the intersection point. Okay, so I'm looking for what the intersection point of the lines is going to be. So what is the solution? Well, this point has an x value that would be x equals 2, and it would have a y value that would go over to the y-axis here, and it would hit it at -1. So the solution to this system of equations would be x equals 2, and then y equals -1. Okay, and then once again, the solution is the intersection point. Okay, so just write the solution as an ordered pair. Okay, no problem. Your x coordinate would be 2, and your y coordinate would be -1. So that's my solution to that system. Okay, let's look at another one. It says consider the system of equations 2x plus y equals 2, x minus 3y equals 15. First things first, we want to graph this system of equations without using technology. Okay, so we'll call this one L1, and then we'll call this one L2. And again, the way that I'm going to get my points is I'm going to write in y equals mx plus b form, figure out what the slope and the y-intercept is, and plot the points based on that. Again, there are other ways to do this. You could figure out the x and y-intercept, plot those points, and connect the dots. But I'm just going to stick with this method for this lesson here. Okay, so line 1 is 2x plus y is equal to 2. I want to get it in y equals mx plus b form, so I'm going to subtract 2x from both sides of the equation. And then I would have y would be equal to -2x plus 2. Therefore, my slope, m, would be -2, and my y-intercept would be equal to +2. Okay, so let's go ahead and plot this. So on the graph here, my y-intercept would be +2. And then to draw the slope triangle, to get a slope triangle that have a slope of -2, what we could do is we could write down a rise of -2 divided by a run of +1. So let's do this in red. Okay, so a rise of -2 means go down by 2. So we're going to go down here. And then I'm going to have my rise equals -2. And then we're going to go across. My run is going to be 1. So again, here, this is the rise. This is the run. Go across by 1. It's just a really tiny run. So my run would be equal to 1. And then I just need to connect the dots here. Okay, so I'll do it with a blue line. Okay, so let's grab a blue line. See if you can connect these dots. Again, this is going to be much easier for you to do. Let's see. How's that? Passable. Okay. Okay, let's draw the arrows at the end. Okay, arrow at the end here, arrow at the end there, and that's going to represent line number 1. Okay, now let's draw line number 2. Okay, so line 2. So I have x minus 3y equals 15. Now, in y equals mx plus b form, I want the coefficient in front of y to be positive. So this time around, I'm going to add 3y to both sides of the equation. Add 3y. So then this would be x is equal to 3y plus 15. But I don't want this 15 here, so I'll get rid of it to isolate the y. Minus 15, minus 15. And then I would have 3y is equal to x minus 15. To get the y by itself, divide both sides of the equation by 3. So if I divide by 3, divide by 3, these 3's cancel off. And then I would have y would be equal to, let's do it over here. Okay, so then this would be y is equal to, x over 3 would just be 1 over 3x, and then minus 15 over 3. So again, take each term in the numerator, divide by the denominator, and this would give you an equation that's y is equal to 1 over 3x minus 5. Okay, so let's plot this graph. Let's do it in green here. Oh, let's clarify what the intercepts are. Okay, so here, okay, the slope is 1 over 3, and the y-intercept is -5. Okay, now let's plot that. Okay, so my y-intercept starts at -5, so that's going to be located here. And then what I'm going to do is I'm going to draw a slope triangle. And what this slope triangle needs to do is it must have a rise of 1 and a run of 3. So we're going to go up by 1, and then we're going to go across by 1, 2, and then 3. Okay, so this is my run is equal to 3, and this is my rise, which is equal to +1. Okay, so my second point is going to be plotted at the end of the slope triangle, so that's going to be located about right there. Okay, so we got my 2 points. Let's grab a straight line now, connect those dots as best as I can. Okay, let's see if I can do it. So connect the dots here, and then something like that. Okay, and then we'll just draw arrows at the end, and we'll call that line number 2. Okay, so I've plotted my graph of my two lines, and now it says state the solution to the system of equations. Well, what is the solution to a system of equations graphically? It's the point where these two lines have an intersection point. Okay, so this here is the intersection point. Okay, so what's the coordinates of this intersection point? Well, if we look here, this would hit the x-axis at, looks like +3. So I could say x is equal to 3. And then the y-axis, it goes across here. Looks like it hits it at -4. So you have y would be equal to -4. And you could also state the solution as an ordered pair, in which case it would be 3, -4. Now, C says algebraically verify this is the solution to the equation by plugging these numbers back into the original equations. All right. Okay, so let's go back to our original equations. Okay, so line 1 had an original equation of 2x plus y is equal to 2. And then line 2 has an equation of, I think it was x minus 3y is equal to 15. Okay, so what I'm going to do is I'm going to verify this by taking the value of x of 3, plug it in for x, take the value of y equals 4, plug it in for y, and then see if both sides of the equation are equal to each other. If they are, then I've verified that this is the correct solution. So the solution would satisfy the equation. Okay, so let's prove this is actually true. Okay, so we go 2 multiplied by x, which is 3. So 2 times 3 plus -4 is equal to +2. Okay, 2 times 3 is 6. Plus -4 would just be subtracting 4. So you'd have 6 minus 4 is equal to 2. And then 6 minus 4 is 2. Therefore, you'd have 2 is equal to 2. Put a little check mark there to confirm that it is verified. Okay, so when you plug x and y in, both sides of the equation are equal, which they must be. Okay, this equation, let's plug in x equals 3. Subtract 3 times y, which is -4. Okay, and that's equal to +15. Okay, so we have 3. Now, -3 times -4 would be +12. So we're going to add 12. And then 3 plus 12 would be 15. So you'd have 15 is equal to 15. Because both sides of the equation are equal, we verified that x equals 3, y equals -4 is the correct solution to this system of equations. Now, this was doing it graphically by hand. Turns out we can also use our calculator to help us do this as well. The calculator can actually, there's a built-in function that can actually tell us what the intersection point is in the calculator. Okay, rather than just going through all these steps right here, I'm just going to, I'll do the example, and then as I go through the example, I will just simply tell you, I'll tell you like, kind of like just talk about the steps as I go through it. Okay, so it says, consider the following system of equations from the beginning of the lesson. That says, rewrite each equation in slope y-intercept form. Now, we already did this, okay, from example 1. Okay, because if we go back to the first example, when I plotted the graphs, I put them in y equals mx plus b form, okay? So equation 1 was y equals -3x plus 11, and equation 2 is y equals -2 over 3x plus 4. So let's just rewrite those equations out. So we'll go back over here. Okay, so L1, the equation that we rewrote it as was y is equal to -3x plus 11. And then L2, we already did this work, y is equal to negative 2 over 3x plus 4. Okay, now it says use a graphing calculator to graph each equation. Okay, now the way to put it in the graphing calculator is you can only plug it in the graphing calculator if you write it in y equals mx plus b form. So what I'm going to do here is I'm going to take this equation and enter it in for y1. So in y1, I'm going to have negative 3x plus 11. And then this equation, I'm going to enter y2, the second equation, is equal to, now, because if I have a fraction, I'm going to put the fraction in brackets. So I'm going to write it down as negative 2 over 3x plus 4. Okay, now I'm going to show you what this looks like. So let's just clear this. Let's enter my equations in. Okay, so the first equation in y1, I'm going to enter negative 3x plus 11. And then in the second equation, I'm going to enter in brackets, negative 2 divided by 3x. And then I'm going to add 4. Okay, now let's graph this and see what happens. We might have to adjust the window settings. Okay, so generally what you want to do is for your window settings, you want to be able to see the x and y intercept of both graphs. Now, the graph in red, I can see the x and y intercept, no problem, but the graph in blue, I cannot, okay? So this would be under Zoom standard, by the way. Like this is the graph that we're starting off with, the Zoom standard. Okay, so all I need to do is I just need to tweak the y maximum just to include a few more of these little grid lines here. So I'll just go to the window, and then in the place of y max, so what it's telling you here is that the biggest y value on the grid is positive 10. So how about we turn it to 15? Okay, just make it a little bit bigger. Okay, let's go back to the graph now. Okay, so now the biggest y value at the top here is positive 15, and now I can see the x and y intercepts for both graphs. Okay, now if I want to state the window settings, I could write it like this. So if I go back here, I could just write down x. Okay, the minimum x value is negative 10. Maximum 1 is positive 10. And then 1. And then y. We just made a small tweak to it. So for y, we went from negative 10 to positive 15. And then 1. Okay, now D says solve the system of equations using the feature on the graphing calculator. Okay, so let's go back here now. All right, so here's how we do it. We've plotted the graphs. Now I'm going to hit these buttons. I'm going to hit the second button, and then I'm going to hit the button that says trace, which has a calculation above it. So hit second, trace. Now, we used this function before to figure out like a 0, which is an x-intercept, or a value where we get a y-intercept from. But the function I want to use here is an intersect. Okay, an intersect is going to give me the intersection point between a couple of lines. So I hit 5. Now, what it's going to do is it's going to prompt you. It's going to say first curve, comma, with a question mark. So I can see a cursor on like my first. I don't know why they call it a curve. It's a line. But what I'm going to do is I'm going to take this flashing little dot, and I'm going to just move it as close to the intersection point as I possibly can get. Okay, and then hit enter. And then the second graph has this cursor on it. And again, what you want to do is move that cursor so it's as close to the intersection point as you can get. Hit enter. It's then going to ask you to guess what the solution or the intersection point is. I don't know why they call it a guess, because it's going to give you an exact number. And it flat out tells you here what the intersection point is. It says the intersection point is when x equals 3 and y equals 2. So if we go back here, we'd have x is equal to 3, y is equal to 2. or if we read it as an ordered pair, it'd be 3, 2. Okay, let's go to the last page. Okay, it says if a decimal value appears for the x and y coordinate, we can convert it to an exact value using the following keystrokes. Okay, we've actually already done this before previously, so just be a bit of a review as to how we do it. Okay, so how about we go through the example and then we'll see what this looks like. Okay, so it says solve the following system of equations using a graphing calculator. So you have 6a plus 7b equals 5, and 3a is equal to 14b. Now, immediately you might get confused because you're like, okay, why are they using the variables x or a and b instead of x and y? Well, we can make a small little conversion here to use the variables we're more comfortable with. So what I'm going to do is I will replace x with a and replace y with b. Okay, so then we can then write line 1 as being 6x plus 7y is equal to 5. Now, to plot it on the graphing calculator, you have to isolate y. So let's subtract 6x from both sides. Subtract 6x. Then this will give me 7y would be equal to negative 6x plus 5. Get the y by itself by dividing by 7. Divide by 7. These 7's cancel, and then we'll get y is equal to negative 6 over 7 is a fraction that does not reduce. You have negative 6 over 7x plus 5 over 7. Okay, so to plug in the graphing calculator, we'll enter it in for y1. So we'll enter in for y1. Again, fraction, put in brackets, so negative 6 over 7x plus, and I guess here you could write down 5 over 7. Now, L2, quite a bit easier to do. So L2, if we replace a with x and b with y, we would then have 3x is equal to 14y. Okay, let's get the y isolated. So divide by 14, divide by 14. So this will just tell you that y is equal to 3 over 14x. When we enter it in our calculator, we're going to plug it in for y2, and we're going to plug it in as 3 over 14x. Okay, so the equations I'm going to plug in the calculator are these two. So we have negative 6 over 7x plus 5 over 7 and 3 over 14x. Okay, so let's go to my graphing calculator and let's get rid of these two equations by hitting clear. Okay, so the first equation I'm going to plug in is going to be in brackets, negative 6 over, again, fractions division, 7x plus 5 over 7. Okay, that's going to be the first equation, negative 6 over 7x plus 5 over 7. And the second equation is going to be 3 over 14x. And then let's see what happens if we do the zoom standard here. So zoom standard, which just goes from negative 10 to positive 10 on the x and y axis. So I can hit the 6. This one's fine, okay? So this one, I can see both the x and y intercepts for both the graphs, and I can also see what the intersection point is. Okay, so now we'll use that intersect function. So we'll go second, hit the trace button, which is going to access calculate, select 5 for intersect. And then again, what you want to do is on the first line, move that cursor as close to the intersection point as possible and hit enter. And then same thing with the cursor on the second line, move it as close to the intersection point as possible hit enter again. Now, the problem here is it gives X and Y values that are either repeating decimals or just numbers that are like really, really ugly. So we want to use the calculator to, I mean, if the problem said give the solution to the nearest tenth of a decimal, no problem, but it does want it as an exact value. Okay, so we need to turn these guys into fractions. So here's how we do it. Okay, so we're going to hit second and then mode to quit this. Now, what I want to do is, what the calculator's done is, so we want second calc intersect. Yeah, okay, so intersect. So the calculator now has this value stored in X and it has this value stored in Y. So what we need to do is we need to find a way to bring up those values and then just turn them into a fraction. So here, if I go second quit, let's do the X first. So what I would do is I would hit the X button and then hit math. And then the first math function is fractions. You can just hit 1 or enter and then hit enter again. And then it automatically converts that value of that stored value of X to a fraction. So it's going to be 2/3. Therefore, here we can say X is equal to 2/3. And then accessing Y is a little more difficult. So we need to use the alpha function now to do it. So the X function is just this button that has like X, T, the Greek letter theta, and N. The alpha button we have to hit, to get Y, we have to hit alpha and then look for the letter Y. The letter Y is attached to this number 1 here because it's on the 1 and it's just up and towards the right. So we hit alpha and 1, then it brings up Y. And then we just use the fraction function again. So we'd hit mode and then, sorry, not mode, math, 1 for fraction. Oh, what happened to my Y? Let's go back here. Okay, so let's go alpha, Y, and then math, fraction, and then hit enter. And then it turns it into a fraction for me, which is going to be 1/7. Okay, so we can go back to here, and then Y would be 1/7. Therefore, if I want to write this solution to the system as an ordered pair, you could write down 2/3 and 1/7. Okay, and then finally it says algebraically verify my solution. So what I'm going to do is I'm going to take these values for X and Y and just plug them into the equations. Okay, now I should point out, by the way, that we initially didn't start off with X and Y. We had A and B. So technically speaking, the solution here would be A is equal to 2/3, and it would be B is equal to 1/7. Okay, we just replaced X with A and B with Y. Okay, so now let's go back to my two equations. So line 1. So let's start off with 6A plus 7B is equal to 5. And then line 2, which is 3A, is 14B. And what I'm going to do is I'm going to take A, replace it with 2/3. Then I'm going to take B, and I'm going to replace it with 1/7. We're going to see if both sides of the equation are equal to each other. Okay, so then I would have 6 times A. Okay, A is 2/3 plus 7 times 1/7 is equal to 5. Now you could do some fraction reduction right here if you wanted to, otherwise you just multiply these together. So 6 times 2 would be 12/3 plus 7 times 1 would be 7/7 is equal to 5. Okay, 12/3 is 4 plus 7/7, which is 1. And then 4 plus 1 is 5. So on both sides of the equation, you'd have 5 equals 5. Therefore, it's verified. This one, let's replace A with 2/3. So we'd have 2/3. And then 14 multiplied by 1/7 Again, if you want, you could reduce the fractions right now, but I can multiply them out. 3 times 2 is 6. You'd have 6 over 3 is equal to 14 times 1 is 14 divided by 7. 6 over 3 is 2. And then 14 divided by 7 is also 2. Therefore, it is verified. The solution is A equals 2/3 and B equals 1 over 7. Okay, I guess we could box those to kind of make them stand out a bit as the actual solution to the system of equation. And again, the solution is the intersection point. Okay, so that's it for this lesson. And you can practice this by doing numbers 2, 3, 4, and 6. Now, just a couple things about this. So for number 6, I believe 6 is like a multiple choice question. No, it's a numerical response question. Okay, so even though it's numerical response, I want you to show your work. Like, how do you actually get that numerical value? And then for questions 3 and 4, only do parts B, D, and F. So every second question. And it'll tell you to verify, but you don't need to verify, okay? So no need to verify. Okay, I'll let you, for number 2, you can do a verification. Okay, that's it for this lesson. And then in the next one, we'll talk about the number of solutions you can have in a system of equations. And I will talk to you then.